Hello everyone, welcome to our pre-calculus class. This is our lesson 15, finding exact values of trigonometric functions using sum and different formulas. And these are from section 7.5 from our book. So this is the agenda, finding the exact value of each expressions, single trig and then more than one functions. So this is combined kind and this is like single function. First of all, these are the sum and different formulas, how they work. So say cos alpha plus beta, this alpha and beta, they represent some angle. Cos alpha plus beta equals to cos alpha cos beta minus sin alpha sin beta. This way we have the formula for cos alpha plus beta, cos alpha minus beta. Same way sin alpha plus beta, sin alpha minus beta. And then tan alpha plus beta, tan alpha minus beta. So we have some set of formulas for sine, cos, and tan. And how this formula comes, if you are interested, how this formula comes, there are a couple of explanations in the book. And for the first one, cosine, this is they try to prove the cos alpha minus beta equals to how we get cos alpha minus beta equals to how we get cos alpha cos beta plus sin alpha sin beta. So they actually tried to prove, this is the first page of this 7.5, as you can see, you will also see it in the book. So they thought that I will just briefly give you the idea what they are trying to discuss here. This is not necessary for you all to memorize all these things. Just if anyone is curious about how this formula comes, this is one very classic example, very good example, uh, how they come to this point. So first of all, let's consider a couple of points here. First point, this is P1, then some point P2, and consider some angle in the point. So let's say this point will be something, let's say 2, 3, 1, 5, or some other values, whatever we have it here. Actually, if we think about the unit circle, then there are some restriction in the value. Value has to be between 0 and 1. So whatever. So about from cos and sine, suppose it will be cos some value of cosine here, some value of sine here. We just write yes cos beta and sine beta due to the angle. Due to the angle. And this is cos alpha sin alpha at this point. This point we just give some name, and we are restricting our points within 0. You will see this. You will see this here. We are restricting now our points between 0 and 2 pi so that we can prove the theorem here. But it will work for bigger things also. So, so we have 2 points P1 and P2, and then we choose our third point P3 in such a way so that we can, if we subtract alpha minus beta, we get our new angle, alpha minus beta. Alpha is our total angle. See, alpha is from here. Let me give you an example. What does it mean? Suppose cos alpha is here, from here to here. Let's say, just for example, suppose cos alpha is, suppose 110 degree. Because it is 90 degree, then something more, let's say 20 degree more here. We are just estimating it. No need to look at this very seriously here. And beta, suppose this beta is, let's say 30 or 40 degree, something like that. Suppose 30 degree or 40 degree. It looks like 40 degree. Okay, suppose beta is 40 degree. This is alpha, this is beta. Alpha and this is beta. So this is 110 degree, this is 40 degree. So if we subtract 110 and 40, then we get actually alpha minus beta. This alpha minus beta will give us that value. So 110 minus 40, that means actually it is 70 degree. This is 70 degree. So this 70 degree is the new angle. This 70 degree is the new angle here. This 70 degree is the new angle here. And actually this 70 degree will be this angle also. This angle will also be 70 degree because total is 110 and this is 40. So 110 minus 40 equals to this 70. This is a little bit important in this proof, and why it is important in this proof is because at a point we have to prove that this two triangle is congruent. And to prove it congruent, we need this angle to be equal, because to prove something something congruent, we need to prove three things of a triangle equal to the three things of the other triangle. And here already we can see this, this is the radius, this is the radius, so this two is equal to these two thing, these two line. So this for all four of them is equal to each other because they are the radius of the circle. And then this angle and this angle, if they are equal, then we can say that these two triangles are congruent. Congruent means now the third side will also be equal. And actually they tried to use that concept for developing the proof of this one. So we can actually find out the distance of these 2 points, because we know the distance formula, distance d equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. That is also actually a Pythagorean theorem, by the way. So we can find out the distance of these 2 points and then the distance of these 2 points. And based on our congruency of these two triangle, actually we can say that this side will be equals to this side. So this is the this is all the thing that they said in all these sentences, up until here. What I said is all this thing. So they are trying to say that distance of that two line is equals to the distance of that two lines are equal. The thing that I showed here, this one and then this one. These two line has to be equal based on the theorem. Because if they are congruent, then all the sides will be equal, and you need to actually prove three things to be equal. And the remaining thing is just the calculation. This is the distance formula. This is also the distance formula between these 2 points P1, P2 and A and P3. So we can use this distance formula. Then this is A minus B whole square. A minus B whole square formula, we will be using it here. A square minus twice A plus B square. And this is also A minus B whole square. So this is 0. That's why we do not have to do anything about this. This is A minus B whole square. This is also A minus B whole square. Then you do just some simple calculation, and then you will arrive here where you have minus 2, minus 2, minus 2 everywhere. Just you cancel out all the minus 2. Then you get the cos alpha minus beta equals to this and this. So we get this. Just only one thing here that you will need to notice carefully. There is like this term and this term is vanished in this line. Just they wrote here 2 because cos square alpha minus beta, then sin square alpha minus beta, these two things, cos square alpha minus beta and sin square alpha minus beta, this plus this equals to 1. And there is another one here, so total is 2. That's why they wrote here 2. The remaining other calculations I have looked, and I think you will easily understand. Just only this thing is one thing, and then all other things is actually written here. This is the distance formula, then square both side. If you square both side, then the square root will be cancelled out, then multiply out the square terms, like the a plus b or a minus b whole square. In this case, a minus b whole square. Pythagorean identity 3 times for connecting them. Then subtract 2 from each side. Divide is, so all the things is written here also, just if you are interested. Anyhow, so this is how we get this formula, and this way they actually, from this formula they actually try to establish other formulas also. If you're interested, you can just a little bit go ahead here. Just if we replace beta by minus beta, then we can come to this property by using the even order identities. So this is how they establish, and other formulas also actually we can establish in some way. But this is the easier one. That's why they actually started from here. So I was talking about this kind of formulas. This is the first one, cos alpha plus beta equals to how they get the cos alpha cos beta minus sin alpha sin beta. So this kind of thing. Now, where we will use it? I mean, why we are learning all these big formulas? Why? What is wrong here? The reason is, sometimes if some, let me show you one math from the book, then we will solve some math from our. Suppose if you have some angle 75 degree, cos 75 degree in this case. Now, how can you solve this math? Like, we do not know the answer of cos 75. We do not know it. But we know cos 45 and 30 because they are some standard values that we already know. And also, if we don't know, we can find out them very easily. So 75 degree cos 75 degree here, we can write it as 45 plus 30. So 45, from 45 plus 30 we can actually find it out. 75, then cos 45 plus 30, so it becomes, this 75 becomes cos 45 plus 30. Then we can use that formula, cos a plus b equals to cos a cos b minus sin a sin b, or in terms of alpha, cos alpha plus beta equals to cos alpha cos beta minus sin alpha sin beta. So then cos 45 degree equals to what? We know it. Cos 30 degree equals to what? We know it. Sin 45 degree equals to what? We know that. Cos 30 degree equals to what? We know that. Then these are just some numbers. We can just work on the numbers to get some solution. Okay, so this is where all this sum of different angles, that kind of formulas, this is where they help us in solving complicated problems, or in solving with the angles that we do not know. Eh, so it makes our life easier in a sense. This is another example relating to pi by 2, pi by 12. So this value also cos pi by 12. This value also we do not know. That's why we can just break it down into smaller pieces, and then we can use the formula to find out the solution. Let's try to solve some maths by using these formulas. So we have one math here. This is cos 7 pi by 7 pi divided by 12. So this cos 7 pi divided by 12, this value also we do not know. So what can we do here is we can write, what do I do? Okay, let's write cos. So this cos 7 pi divided by 12, we can write it as this. See, this is 12. Then let's write 12 here. 7 7 we can break in a way like 3 pi then 4 pi. So 3 plus 4 equals to 7. So we can write like 4 pi then plus 3 pi. We kept our denominator same, so we can, that's why we can add this way. Okay, then cos, so we have this, if we do the cancellation, this will be pi by 3. Then if we do the cancellation, this will become pi by 4. Now cos a plus b, or cos alpha plus beta is, this is the formula. That means we have to use this formula now. That means cos alpha cos beta first of all. So cos alpha means this, then cos beta means this, then minus sin alpha sin beta. So sin alpha, then sin beta. So sin beta. Now cos this cos of pi by 3, cos pi by 3 means cos 60 degree. Cos 60 degree means 1 by, cos 60 degree means 1 divided by 2, then into cos pi by 4, so this means root 2 by 2, then minus sin pi by 3. Sin pi by 3 means sin 60 degree, which is root 3 by 2, then sin this means root 2 by 2, sin 45 degree, root 2 by 2. The remaining task is just simplification, so you can write equal to everywhere just to make sure that we are doing everything correct. So this is actually root 2 by 4. This is actually root 3 into root 2 divided by 4. So we can, in one line, if I write, I think you will understand. We can write it in see if you understand that 1 divided by 4, if I take, because 1 divided by 4 is here, 1 divided by 4 is here, so if I take 1 divided by 4 common, it will become root 2 minus, this is root 3, this is root 2, so total is root 6, because inside the root we can multiply them, that's why. And this is the answer actually for this math. So uh, that's the end of this math. Hmm. Let's do another math. Let's solve another math. This is sine 17 pi divided by 12. So for this math, look at this math. This math is how can we break it down? How can we break it down? 17 pi divided by 12. So if we break it down, 12, 7. So there is less easier way. I mean, you can try. Then if you get some other ways, you can let me know. We can, of course, we can use it. So one approach is, look, this way also you can solve. This way also you can solve. The way is, since we know that sine theta, this sine has the period 2 pi. So if you write 2 pi here, then this is 12. See, this, if I write 12 here, I cannot give here plus, because if I give plus here, then 12 into 2 means 24. 24 plus something will be a big angle. We are trying to make this 17 pi here. So if I give minus here, this is 24. 12 into 2 means 24. 24 pi minus 7 pi equals to actually this 17 pi. This value equals to 17 pi. Why we are writing it this way? The reason is, if we can write the sine or cosine as even integer multiple of pi, like 2 pi, 4 pi, 6 pi, then actually we can just remove this entire number and we can write this only, because they have the same period, and we know that the sine and cosine will repeat after this value. So we can write this thing, just only this. Now our math became just little bit simpler, like 17 pi divided by 12. Now it is just 7 pi divided by 12. But we have one minus sign inside the bracket, and we know that since this for the sign, this minus will come out. So basically it will be like sine 7 pi divided by 12, due to the even odd property of the sine, cosine, and tan. We know that for sine and tan, minus sign comes out, and for cosine, cos of minus theta equals to cos theta. It becomes like that. So now we have our form in some easily solvable situation. We find ourselves there. Sine. So this is like somewhat like our previous math now. 4 pi divided by 12 plus 3 pi divided by 12. This is just somewhat like our previous math. Let's put equal to sign here, equal to sign here, equal to sign here, equal to sign here. Then we can use sine alpha plus beta formula. Sine alpha plus beta is this formula. Sine alpha cos beta plus cos alpha sine beta. But before we do that, before we use the formula, let's simplify it a bit, so that we can put the value very comfortably. So this is pi by this 4, so this is 3. Then this is pi by 4. Then we can write minus sine. So sine alpha cos beta. Sine alpha means pi by 3. Cos beta means cos pi by 4. Let's keep the bracket out, minus sign outside the bracket for our safety. For our safety means for so that this minus is not disturbing anywhere inside the math. We can deal with it later if necessary. Then cos alpha sin beta. So cos alpha, alpha means the first angle. So this is pi by 3. Then sin beta means sin second angle. Sin pi by 4. Then we can just put the value here. So minus sin pi by 3. Pi by 3 means 60 degrees. Sin 60 degree means root 3 by 2. Then cos this means root 2 by 2, 45 degree. Then we have some plus sign here. This is plus positive sign here. So this is plus cos pi by 3. Cos pi by 3 means 1 by 2. Then sin pi by 4. Sin pi by 4 means root 2 by 2. So this is also somewhat similar actually. We can take this 4 common, 1 by 4 common in one line if we want. Then it becomes root 6 plus root 2. Actually, if we want, we can take this root 2 also common. If we take root 2 common, then answer will be root 3 plus 1. Root 3 plus 1. That actually looks little bit that looks little bit better to me. So this equals to will be minus root 2 by 4. If I take that root 2 common from this line, root 2 by 4 common, then it will become root 3 plus 1. This will be the answer if we take that common. But in our book, answer is written this way, because I think their logic is so that this irrational part is inside the bracket. I think this is how they thought. But this is also, in my understanding, this is also a very acceptable answer. No problem. But this one is the best based on the logic. Okay, so this is how we can use all these formulas. If the math is tan related, just use the tan formula. That's it. There is no big difference. So this kind of more maths are here. This kind of more maths are here, and we will try to solve few more during the class from here. And you can ask the questions if you have during the class time. And now this is another type where multiple angles are involved in this maths. Look at this. This is 24 number from the section 7.5. And how do we do this math? This is sine 20 cos 80 minus cos 20 minus sine 80. And this math is look at this. Which formula is matching here? The angles are a little bit funny here because if you look at the angle, this is 20, 80. We do not know the answer of 20 or we do not know the answer of 80. And if we try to break it down inside the bracket within this, then actually this is becoming more uncomfortable, the math. So our task here is to find out this thing is matching with which formula here in the right hand side. So that will actually help us. Look at this, sine alpha cos beta minus cos alpha sine beta. So which formula is matching here? Is it this one? Sine alpha cos beta minus cos alpha sine beta. So this is actually this form. This is sine alpha minus beta. So this is sine. Now if you ask, sir, how do you know all of a sudden that formula is involved? Of course now you can see it. The reason is always look at the cos formula. In the cosine formula, this is cos. This is also cos. So this first term here is cos and sine both together. That means this formula has to be related to sine formula. So either this will be this formula or this formula. Now since this is negative, so it has to be the second formula from the sine. This is how you can understand it, which formula is coming. Now this is sine, so it is sine formula. And notice that actually this math is a little bit, I have chosen this math so that this actually serve two different purposes. One purpose is to regular thing, the formula. Another purpose is how do you choose wisely the term, which one is alpha, which one is beta. Now if you choose 20 minus 80, then you will get some negative answer, negative thing here. 20 minus 80, negative uh, 60 degree. But you see, if we can actually rearrange it a bit. We can actually think this from different angle also, different perspective also, if they serve our purpose. So you see here, this is 20. Anyway, let's just directly we can follow the process, because we have our even odd property in our case. So 20 degree minus 80 degree. What I was trying to say is, if you see that after rearranging it helps, then actually you can rearrange it and in any math if you need. But here it does not help. It does not help. Suppose if you write cos 80 sine 20, that is good, but the problem is that's not actually matching with our formula. So that's not helpful. So we can write sine minus 60 degree. And sine minus 60 degree means, first of all, let's just bring our negative sign outside the bracket, and then we have just sine 60 degree. This equals to minus, so 60 degree means root 3 by 2. Just let's write root 3 by 2 now here. So this is the answer. Yeah? This is the answer. So for this kind of math, our first goal is to just match with which formula this given expression is matching. Then we can just go ahead and do something about that. Let's do another math from the same type, same category. This is cos. So from this we can easily develop our idea, and we can say that this is cos related formula. And in the cosine related formula, you will notice our this is the formula, because it is plus sign. So this second formula is actually matching with our with this given question. So cos alpha minus beta has to be the formula here. Now, just as I said in the previous slide, if you see somewhere rearranging helps you, then actually you should do that. Just like, see, cos 5 pi by 12, if you write first this big value, then cos pi by 12, then actually you can just shuffle it here also. We can just write it here also, because sine 5 pi by 12 and sine pi by 12 and sine pi by 12, sine 5 pi by 12, they are actually same thing. My point is, if you write it first and if you write it second, they will mean the same thing, and they actually this actually is not changing our formula. So the problem is mosquito is actually disturbing me. Fan is off for the recording, so mosquito got some chance now. Yeah, I was not ready for that, so that's why they are disturbing me. Yeah, sorry about that. Anyway, so what I was trying to say here is, see, so cos alpha minus beta. What I am thinking here is, I can consider this alpha here in this math. Other way is also possible. I will show you in the other way also. So I can write here 5 pi by 12 as this is alpha, and then pi by 12. So we can write it this way. Then we will have, because it is alpha minus beta, that's why, and we consider this bigger value as alpha, so that subtraction, in the subtraction it helps us, that's why. Cos So this is 5 pi minus pi, that means 4 pi, 4 pi by 12, and we already know 4 pi by 12 means basically pi by 3, and this means 4 pi by 12 means pi by 3, and cos pi by 3 means we can directly write the answer, or just if you want I can write pi by 3 here, and cos pi by 3 means 1 by 2. And the other way is, as I said, I will show the other way. Other way is just keep it as it is, then it will be like cos. Not too difficult, I think. That way also understandably easy, because now actually you all know the even odd property very well. So this should not be a difficult thing for you. So we can write cos. So it will become minus 4 pi by 12. So what happened here is just we got a negative sign here, extra negative sign. But good news is for cos, negative sign does not mean anything, does not disturb at all, because cos of minus theta means cos theta, just simply cos theta. So this is just simply cos 4 pi by 12, or pi by 3. So you see this line and this line is now same. Now the remaining calculation is same, and you get the same answer, 1 by 2. Okay, so our first task is to find out which formula will match, and then just go ahead and do some calculation for that. This is one more math from the same category. So we have tan 20 plus tan 25, then 1 minus tan 20 25. I think this is easily matching with this formula. So this is tan alpha plus beta, so this will become tan alpha plus beta, that means 20 plus 25. So 20 plus 25 means tan 45, and this math is this math looks pretty straightforward answer. Tan 45 degree means 1, so we can just write here 1. Okay. So, and there are more maths from these sections for your practice. These are the math you will try to practice from these two category. There are actually one more category here. First, in my first plan, I thought that we will discuss all that section also with this video, but it seems like it is taking a little bit more time, and we can discuss this in a separate class, because that topic is a little bit bigger, that's why, which is related to the given condition. If you read the book, you will see that there is another type of math from page number in the page number 481, 33 number to 38 number. So that kind of math will require another day. Plus we may add some other new things with that topic. So that's my plan. And that's all for today's class, and you can try to practice these maths, or if you have time, just practice all the math from all the math from these sections, because it will not take too much time. Also all the math from these sections also, if you have time. Okay, so that later we can discuss also if there is some problem. So that's all for today. Thank you all, thank you very much, and have a good time. See you all in the class. Bye bye.